This video will go through the sequencing system of a 1965 to 1966 Thunderbird sequencing turn signal lights in the rear of the vehicle. The tail end of the 1964 through 1966 Thunderbirds are the most elegant ever designed in my opinion. Other vehicles of the time also used the sequential turn signal system like the Shelby Mustangs and the Mercury Cougar, but they were not nearly as elegant, again my opinion. The sequential turn signal system used on these vehicles is more complex than vehicles which use a single turn signal light, as you might expect. As you view this video, there will be the word pause spoken and a short delay before moving to the next slide. When you hear the word pause, you can pause the video if additional study time is required. Also, the individual slides used in this video can be printed out for your use troubleshooting your system. To do this, pause the video with the slide desired on the screen. Then press the PRTSCR key on your keyboard. That will put the slide image in the clipboard where it can be pasted into Paint of some other image editor to be printed. Slide 1. This slide is a simplified schematic diagram of the turn signal and brake signal systems. It was taken from the 1966 Thunderbird shop manual. The wire numbers and the wire colors noted in the diagram should be the same for a 1965 Thunderbird. Please note the colors used on the diagram for the wiring. It's not intended to be representative of the actual color of the wires in the vehicle. Rather, the wire colors shown in the diagram are used to denote the voltage condition that exists in the wire at any given time. The wire color codes for the slides are: black denotes the wire is at ground or at 0 volts. Red denotes the wire is at plus 12 volts. Green denotes a movable switch contact. Blue denotes the sequencer inside light path. Violet denotes the sequencer middle light path. Orange denotes the sequencer outside light path. 12-volt power begins obviously at the fuse block. There is a green-red wire number 10 from the fuse block to the brake switch which supplies power to the brake switch, regardless of the key position. Also, from the fuse box there is a orange-yellow wire that is fed through a circuit breaker connecting to the turn signal switch in the steering column. There is a stop light relay located in the trunk, which is used to provide power to the two triads of lights. A stop light relay is used because the brake switch is not rated for sufficient amperage to power the 6 brake lights. Notice the power to the brake light relay comes from the hot wire on the brake switch through the brown-white wire 457 and 474. Notice also wire 457 also supplies power to the sequencer park switch. Pause. Slide 2. The device that causes the rear signal lights to sequence is the sequencer. It is located in the trunk under an insulation wrap with the turn signal indicator relay and the stop light relay. The sequencer is a motor-operated cam timer that has 4 cams that operate 4 switch contacts. In the 1965 and 1966 Thunderbirds, there are 2 signal light triads. One for the left turn signal and one for the right turn signal. There is a contact for each turn signal light within a triad, the inside light, the middle light and the outside light. The same contacts in the sequencer are used for both the right and the left turn signal light triads. And the output voltages from these 3 contacts will be diverted to the left or the right turn signal lights by the turn signal relay, which will be described later. The 4th contact is used to park the sequencer at the start of the sequence when the turn signal in use voltage which connects directly to the motor is removed. This is the brown wire. When the sequencer is not at its parked, or start, position, the park switch contacts are closed. This will supply power to the motor through the brown-white wire when the turn signal in use voltage is removed. Turn signal in use voltage is supplied by the brown wire when the turn signal switch is not in the center position, either signaling a right or left turn. When the sequencer has reached the start position, the park switch contact will open, stopping the motor, assuming the turn signal switch is in the center position. Now the sequencer is in position to be ready for another sequencing of a signal light triad. Notice the outputs to the turn signal lights are as follows. 0. All outputs are off. 1. Inside lamp is on. 2. Inside and middle lamps are on. 3. Inside, middle and outside lamps are on. Repeat back at 0 until the turn signal in use voltage is removed, and the sequencer is parked. The sequencer common is also controlled by the turn signal switch, so all of the turn signal lights will go off when the turn signal switch is released. All lamps will go off, even if the sequencer is moving to the parked position. The outputs of the sequencer are connected to the turn signal relay, where they will be diverted to the left or right light triads. The next series of slides will go through the operation of the brake and turn signal system. You can pause the video at each slide if you need more time to follow the circuit paths described. Pause. Slide 3. This slide shows the voltage path for the brake lights with the brake engaged. Notice the brake switch will energize the stop light relay. The contact of the stop light relay will then supply voltage from wire number 474 to the turn signal relay through wire number 476. Notice the turn signal switch is shown centered, thus not energizing either coil of the turn signal relay. When the key is in the off position, even if the turn signal switch is not centered, since there is no power to the turn signal switch. Because the accessory circuit will be off, neither coil will be energized. Power from the brake terminal will flow through the closed turn signal relay contacts out to the brake lights. Since neither the right or the left coil is energized, power flows to all 6 brake lights. Pause. Slide 4. This slide shows the circuit paths with the key on, the brake engaged and the turn signal in the right turn position. If you notice, the stop light relay is energized and the contacts are closed. We have power through the stop light relay contact up to the brake terminal on the turn signal relay. Power goes through the closed contacts of the turn signal relay to the left 3 brake lights, lighting up all 3 left brake lights. Also notice that with the key on we have a hot through the accessory orange-yellow wire to the turn signal switch. When we have the turn signal switch to the right, we have connections between the orange-yellow hot wire and the violet wire number 441. Also, there is a connection between the orange-yellow hot wire and the orange-black wire number 458. The violet wire number 441 is connected to the right coil of the turn signal relay. When it is energized, the right side contacts for the turn signal lights are actuated, opening the connection to the brake path and connecting the path to the sequencer outputs. Backing up to the turn signal switch, the orange-black wire having power. This feeds power to the turn signal indicator relay contact as well as the motor of the sequencer through the brown wire number 456. Now the sequencer motor begins to run and the sequencer park contact closes. Back to the turn signal indicator relay again, power flows through the closed contact back up to the turn signal switch through the brown wire number 694. Power then flows through the turn signal switch out the yellow wire number 363 to the right fender-mounted turn signal indicator. There is also a bullet connector for a dash-mounted turn signal indicator light for use in areas, like foreign countries, that require a dash-mounted turn signal indicator. Again, back to the turn signal relay, the power also flows through the coil to the sequencer common wire for the light switches through the green-orange wire number 459. The green-orange wire number 459 provides power to the sequencer common terminal, and since we're at the beginning of the sequence, the inside light circuit path will have power. The power will flow over into the turn signal relay at the inside light terminal and flow through the closed contacts because we had the right turn signal energized. Now power flows out to the inside light of the right signal light triads. Now I'm going back to the turn signal indicator relay. It's important for you to know that the coil in this relay has a very large size coil and it presents a very small resistance in series with the turn signal lights. There will be more discussion on the turn signal relay later. Pause. Slide 6. This slide shows the circuit paths with the key on, the brake engaged and the turn signal in the right turn position. Now the sequencer has moved to sequence 3 where the inside light, the middle light and the outside light paths are powered. Also the right front turn signal light is powered. The inside path is shown by the blue color. The middle path is shown by the violet color. The outside path is shown by the orange color. As long as the turn signal switch remains in the right position, the sequencer will continue to run, repeating the sequence. Pause. Slide 7.1. This slide shows what I call the reset sequence. It only lasts for a few milliseconds. Referring to the turn signal relay, it is a current-operated relay. It has a very large coil, made of heavy wire, so the resistance is very small. It is designed to open up the contacts only when the 3 lights of the rear triad plus the front turn signal light are on. Only then will there be sufficient current to trigger the relay. All of the signal lights use a number 1157 lamp, each of which consumed 2 1/4 amps operating at 12 volts. Multiplying that by 4 gives us a total of 9 amps when all 4 lights are on. When the turn signal indicator relay is triggered, notice the power to the turn signal switch on the brown wire number 694 is removed. This in turn also removes the power to the fender-mounted turn signal indicator light. Also notice the power to the bullet connector for the optional dash-mounted indicator light is also removed. Additionally, the power to the coil and the power passing through the coil to the common on the sequencer is also removed. At this point in time, all of the turn signal lights as well as the fender-mounted indicator light will lose power and be turned off. It should be noted that the sequencer continued to move beyond the sequence 3 and into the parking sequence. As soon as the power through the coil of the turn signal indicator relay was removed, the relay will reset, reclosing the contact. There is a small delay reaction time for the triggering and the reset of the turn signal indicator relay, which allows the sequencer to have moved into the parking sequence by the time the turn signal relay resets. This will be covered in the next slide. Pause. Slide 7.2. This slide shows what I called the parking sequence. It starts a few milliseconds after the turn signal indicator relay was triggered as described in the previous slide. Since the park switch in the sequencer is still closed and will not open until the sequencer has reached the parked position, the sequencer continues to run. If the turn signal switch is still in the right position, the sequencer will continue to run once it reaches the park position because the voltage supplied by the brown wire number 456 will still be present. If the turn signal switch is now in the center position, when the sequencer reaches the park position and the park switch contact opens, the sequencer will stop. It is now ready to start a new sequence when the turn signal switch is placed in either the left or the right position. Pause. Slide 8. Rather than go through all the sequences with the turn signal switch in the right position and the brakes disengaged. This slide only shows when the sequencer has reached sequence 3 with all 3 lights in the right turn triad are lit. Notice when the brakes are disengaged the brake switch will open, removing power to the coil of the stop light relay. This in turn opens the stop light relay contacts and remove power from wire number 476 at the turn signal relay. Pause. Slide 9.1. Rather than go through all the sequences with the turn signal switch in the left position and the brakes disengaged. This slide only shows when the sequencer has reached sequence 3 with all 3 lights in the left turn triad are lit. Notice when the turn signal switch is in the left turn position, the white wire number 440 is powered, which in turn energizes the left coil of the turn signal relay. This sets the path for the left light triad to be sequenced as previously described for the right light triad. Notice when the brakes are disengaged the brake switch will open, removing power to the coil of the stop light relay. This in turn opens the stop light relay contacts and removes power from wire number 476 at the turn signal relay. Pause. Slide 9.2. Rather than go through all the sequences with the turn signal switch in the left position and the brakes engaged. This slide only shows when the sequencer has reached sequence 3 with all 3 lights in the left turn triad are lit. Notice when the brakes are engaged the brake switch will be closed, providing power to the coil of the stop light relay. This in turn closes the stop light relay contacts and provides power to wire number 476 at the turn signal relay. Since the right turn signal relay coil is not energized, the power flows through the closed contacts to the right light triad. This completes the operational video for the sequential turn signal system used on the 1965 and 1966 Thunderbirds. My next video will go into how to troubleshoot each component in the system, so look for it. Pause.